Search and rotated sorted array. There is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly left rotated at an unknown index k. K is between 1 inclusive and nums.length, so the length of the input array nums, such that the resulting array is nums k num k plus 1 nums n minus 1 num 0 num 1 until nums k minus 1 0 index. For example, 0 1 2 4 5 6 7 might be left rotated by 3 indices and become 4 5 6 7 0 1 2. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums, or -1 if it is not in nums. You must write an algorithm with O log n runtime complexity. So we can't just go through the array, right, one by one and search for 0, because that's a linear time complexity. When it says log n, it usually just implies like a kind of splitting the input array in half, and I'm assuming not assuming, I know that the ascending order is going to help with that. So I did watch the NeetCode video, but even after watching it, I was pretty confused. So I wanted to just make a video on it and see if I can understand how to do this. So let me come here. Just come to the whiteboard. All right. So let me grab this input array over here, and I'll kind of just demonstrate my understanding of this. Maybe explaining it will help me understand. All right, so we have, like, if we had just this array over here, okay, ascending order, and it's not, just an ascending order sorted array, we can apply binary search. And just as a reminder, binary search, I would advise you to complete the binary search question, like the binary search LeetCode question. But just as a reminder, you start it with the middle, right? Or, yeah, so the middle, it would be at this kind of placement right here. And then you'd have like a left and a right pointer. Okay. All right, and then you'd have a target, right? So let's imagine that target is 6. Okay. So you want to do a check. You want to check if whatever value is in the middle, right? Is this value in the middle greater than or less than the target? Okay. Because if it's greater than the target, then it can only be one of these values, right? Like if the target is somewhere in here, then 4 has to be greater than it, according to the definition of what it means to be in ascending order, right? And then if it's less than, then according to the definition of ascending order, it's just got to be in this section, right? And we know our target is 6, okay? So it's got to be in this section over here. And the reason why we know it is because we do a check between the element in the middle and the target, and determined that the element in the middle is less than the target. So we can kind of focus on the second half of the array and just ignore this entire first, right? And then you kind of take a new midpoint and look at 6 now, right? Luckily for us, 6 is the target, so we can return that, like the index, Otherwise, we'd have to kind of continue that process. And the way we can kind of reduce it is we can take this left pointer, right, and just kind of move it to mid plus 1. So now we're just considering this section over here, right? Just this section. And if it was the other way around, then we just move the right pointer. We can move it here, mid, -1, to consider this left section. Kind of like, maybe there is a recursive, I think there should be a recursive way to do this as well, like just passing the right and the left and all that, but this pointer solution that NeetCode showed was really nice. I like it. So that's the general idea of that. Now for something with this, the left kind of, it's an ascending order, but it's shifted to the left by k. Now we see here it's 4, 5, 6, 7, okay, and then 0. So technically here it's not ascending, but if you rotate it back to its original state, it would be an ascending array. But from here, from this part over here, right, and then to this part, this is all ascending. It's just like shifted, rotated. So, and I think my lines kind of demonstrate something here. The lines I drew. It's something that LeetCode showed as well. So let's just do a different color. I'm liking my colors right now. So I showed over here that we're starting from 0, okay? Let me just do the same green. So starting from 0 and going to 2, okay? And then from this section over here, starting and going up to 7. Do you see this? Like, if you move it, if you move this over here, it's still like ascending, like it's still like an ascending pattern. It's just been rotated. So one, we need a login solution, right? So we can't just, like I said earlier, we can't just go through every single element, right? If the target is 0, we can't just go through this entire array and just, when we reach 0, just return the index, because that would be a linear time complexity, right? When I say linear, linear means like it would be fixed to the length of this array in a linear fashion. Like the length of the array is n, you'd have to go worst case through all n elements. By log n, that usually means you want to cut the array in half. So I guess we still want like a
Gemma.